Just like solving equations that have fractions, sometimes you'll run into the decimal. Decimals are easy to get rid of. You're going to only multiply by a power of 10 to get rid of it. And so in other words, if you have one decimal, you multiply by 10. If you have two decimal places, you'd multiply by 100, and so on and so forth. So for this problem, I don't want to work with decimals. I'm going to get rid of them. I multiply by 10. I distribute. And as I distribute, I take care to multiply to each and every term. You can't leave anybody out. And so 10 times 1.3 would simply become 13 minus, multiplying by 10 would be 21x here, equaling 30. Because my coefficient is negative, I'm going to elect to move this term over to the right-hand side. That means that the right-hand side should be only left for variables. The 30 would be in the way, and so I will move it to the left. As I rewrite the problem, anything that was originally there that wasn't migrating should be written first. This 30 comes over as a negative 30, and the negative 21x will go over as a positive 21x. 13 take away 30 would be negative 17. And you always divide by the coefficient. You always divide by the number in front of the variable. So I divide by 21. That leaves me with a proper fraction here. I won't divide this and go to decimals. I'll leave it just as it is. And so I say x equals negative 17 over 21. I'm going to throw another example at you here. And let's do it with a complex fraction. Let me say something like this. Z minus 4 over 6 equals negative 2. With a problem like this, it's very similar to the idea of getting rid of fractions. Anytime I see a fraction, whether it has two parts to the numerator or it's a simple 2/3 or whatever, I'm getting rid of them. It's so much easier to work with the integers. And so in order to get rid of this, I need to multiply by the whole number 6. 6 on the top versus 6 on the bottom. That would allow those to cancel. The only thing that's different is when you have this, what I'm calling a complex fraction here, is that when I multiply, I only have to multiply right here. This is one fraction. It's one term, essentially. And then I multiply there. As I multiply, these 6's cancel. This numerator drops down unchanged. I don't multiply numerators when you have that complex idea. The 6 allowed it to be canceled out. All of that numerator had to come down unchanged. And in a similar way, 6 times negative 2 would be negative 12 on my right-hand side. Variable's positive. It doesn't even have a coefficient, so very simple to solve. All I need to do is move this 4 over. And so I could rewrite this as z equals, original term, negative 12 plus 4. Simplify, z is negative 8.